Hey everyone, so in this video we're going to be talking about Boolean operators. So Boolean operators. Now, what have we already learned about Boolean and Boolean data types? The two things that we basically need to know so far are just the fact that Boolean data types can hold a true or a false. So for example, we might have a variable a, and it might be equal to true with a capital T. And we might have a variable b, which is equal to false with a capital F. Now, with Boolean operators, that's all we need to know so far. And in this video, we're going to be talking about how we can use these Boolean variables to our advantage when we're trying to, control the flow of logic in our programs. So just like with numbers in Python, which we can use different kind of arithmetic operators with. So for example, if we have two numbers, a is equal to 5 and b is equal to 10, we might have, for example, we might want to add them. We might have to do a plus b. We might want to subtract them. We have a minus b. We might want to multiply them, so a times b. We might want to divide them. We can also divide them and then take our result and round it down by using 2 slashes. And we might want to raise a to the power of b. And we can do that with 2 asterisks like this. So this is the equivalent, once again, to a to the power of b. And this is the same thing if you're more familiar with math notation, a divided by b, and take the floored answer. So we can do this with, we can create mathematical or arithmetic expressions using these arithmetic operators. So these values right here are the arithmetic operators. Right, the divide, multiply, add, subtract, exponentiation. So these are all our arithmetic expressions. And what we can do is the same thing in Boolean data types. We can do the exact same thing with Boolean data types in the sense that we can create Boolean expressions using Boolean operators. So what do we mean by that? Well, what I mean by that is we actually have 3 very common operators. So just like the add, subtract, multiply, divide, with Booleans, we have almost the exact same thing. And the way we're going to do that and the supplement for them are, for example, the keyword not. So that's the first type of Boolean operator we have. The second one we have is and. And the last one is or. And we're actually going to talk about these very briefly or very quickly, and then we're going to jump into some examples so you get more familiar with them. So these are our very key operators. And whenever you use it in language, when you're talking to someone, for example, you might say, is it hot or not, right? You're basically asking, is it hot today or is it not hot today? And that would be either true or false, right? So if it is hot, right, then it is indeed hot, so that's true. Or you're saying it's not hot, which could be true, but then we change it to false, right? That's our negative. And with and, we might see some further examples, but we'll look at that later. For or, we might look at a conversation between 2 people. They might say chocolate or vanilla, right? And by picking either of them, you're basically picking any of the options, right? So you're saying vanilla or chocolate, right? Then you picked one of the flavors. But we're actually going to look at an example where these are pretty useful. But let's actually go over each one of these not, and ors. So with the first one, we have not. And with not, if we have 2 variables two Boolean variables. Let's call one like socks, for example. And so this is a Boolean variable as well. And let's say we had another one called sandals. I believe this is how you spell it. I'm not entirely sure. But let's say that we had these two Boolean variables. So we're going to mark these as Boolean, like that. And well, if these are two Boolean variables, by saying not socks, if we write this in our program right now, this is basically going to give you the value of true if and only if the value of socks is already false. So what do I mean by that? Basically, it's going to flip the value of whatever socks was. So if we said socks was equal to true, and what we did was say not socks, and we printed this, let's say we printed not socks, well, this would actually give us a result of false. And let's say socks was false, then not socks has the equivalent value of true. So you can see here that it's basically flipping the value of whatever it originally is. Okay, cool. So that's pretty much what the not variable does, is it basically negates it. It basically changes the value. So if it's false, it becomes true. If it's true, it becomes false. The next one we have is and. Now this one's a very important one. The last two are very, very important. And essentially what the and keyword is, and this is a Boolean operator, is it basically says this. So if we have socks, and let me write that a little bigger and erase this bool. We know that this is going to be a Boolean operator. If we have the expression socks and sandals, then the value of socks and sandals is only true, is going to be, so socks and sandals has the value true if and only if, right, both socks and sandals have the value true. So that's a lot to digest, but we're actually going to look at a table later on about where we can summarize all of these. So socks and sandals has the value true if and only if both socks and sandals have the value true. Now we're going to look once again at a summary table of how this will apply. So in order for this socks and sandals to be true, the whole thing needs to be true. Both socks and sandals need to be true. If either of them are false, then the whole thing will return false. And if both of them are false, then it's going to return false as well. So it's only true if both of them, basically if all of them are true. Okay, so that's that keyword, the and keyword. It's a very important one. And the next one we're going to be talking about is the or keyword. Now the or keyword is also pretty special. And similar to the and, it has its own set of rules as well. So once again, if we had socks and if we had the two variables socks and the variable sandals, well, if we said socks or sandals, well, basically this value, so we can say socks or sandals has the value true if and only if at least one of socks or sandals has the value true. So what does this mean? Basically, if we evaluate socks or sandals, then basically this value can only be true if either one of them is true. So if we said socks was true and sandals was false, then socks or sandals gives us true. If socks was false and sandals was true, well, socks or sandals gives us true. And then if socks or sandals are both true, it gives us true. And now the only time it would be false is if both of them were false. So you can see how if both of them are false, the whole thing will be false. And that means all the other conditions where if there's even one true, the whole thing is true. So that's pretty much the three main Boolean operators that we're going to have to look at in Python. Okay, so now that we know the operators, let's actually try out a summary table on how we might explore this even more. So let's say we had, the variables socks once again, and then we also had sandals. And actually, let's actually use simpler variable names. Let's just say we had the variable p, and let's say we had the variable q. And what I'm going to do is I'm going to make a table of values. So let's go split this down the middle. And we're going to split this like this. Now you're going to see why I make these lines so long, but basically what we're going to have in the next column is not p. Okay. And then in the next column, we're going to have p and q. In the final column, we're going to have p or q. Now let's actually make a truth table. And what a truth table is basically all possibilities of p and q. And this is basically a summary of how the Boolean function or the Boolean operators are going to work. So let's say that p here was true. Let's say q here was true as well. Then let's say true. And then let's say false for this one. Then let's say false for p and true for q. And then finally, false for p and false for q. And so as you can see, these are all the possibilities for p and q, right? Either true or false, and we have all four possibilities here with us. Now let's go through the entire list, and let's go row by row on how we might evaluate these. So first, let's evaluate this not p here. And well, with not p, we can essentially see that with not p, p has a value of true. And so if we say not p, that's negating the Boolean value of whatever p is. So if it was true, it becomes false. If it's false, it becomes true. So in this case, we're going to evaluate this to false. Okay, and yeah. The next one, let's look at p and q. So if you guys remember the rule for and, it's that if there is if there is a single false, then the whole thing becomes false, right? So we need everything to be true for p and q to be true. So in this case, since it's true, true, this value right here is true. The next one is p or q. And with p or q, if you remember, is that if there even is one true, then the whole thing becomes true. So if it said if there's at least one true, if at least p or q is true, then the whole thing is true. So in this case, it's true, true. At least one of them is true, so the value here is going to be true. The next value or the next row is basically p is true and q is false. So what's the value of not p? Well, since that negates true, that gives us false. P and Q. Well, once again, the rule of P and Q is that everything needs to be true for it to be true, right? So in this case, it's true and false. And well, that gives me false then, since not everything is true. With P or Q, we can see that if at least one of them is true, then the whole thing is true. So true or false, that gives me true. With false and true for P and Q respectively, not P is the negation of whatever P is. So that's false. And now we're going to turn it to whatever it's not. So it's not false. It's not true. So that would be false. And so the value of not P gives me true. P and Q, you can see that both of them are not true. And so therefore it gives me false, since everything needs to be right and everything needs to be true. For P or Q, it says at least one of them needs to be true. So you can see here, at least one of them is true. Whoops. And so this gives me true. Finally, false and false. Not P in this case gives me true because not false gives me true. For P and Q, we can see that it's very restrictive in this case. Not a single one of them is true. And since and basically needs everything to be true, then we can see here that this is false, since not everything is true here. And then finally, for P or Q, it says at least one of them needs to be true. But in this case, we can see that none of them are true, and so this actually gives us false. All right, so that's pretty much the table, and this table is called a truth table. And this basically summarizes all the possible scenarios for some amount of variables. Okay, so now let's actually look at a few examples of where this can be applied. So let's look at a few examples. Let's say we had the Boolean expressions already defined. So let's say P was equal to true. So some variable P is true. Let's say Q is equal to false. And let's say R is equal to false as well. And then finally, let's say there's a variable S, and this is equal to true. Okay, so we're going to go over a number of these, and let's look at exactly how we might do this. So first, let's start off with number 1. So let's go with A. Well, for my first question, I'm going to say, what is the value of not? And this would be in other variable or other languages, but in Python, we have to use the word not. So what would the variable or what would the expression of this Boolean expression give me? So not P. And you guys can feel free to pause the videos before I answer it. But for not P, let's see what it would give me. So P has a value of true, and negating it with not gives me false. So this value right here, and let me see if I can move this red over. And let's change it to red. So you can see here that this would actually give me false. Okay, so once again, not P, because it's not true, gives me false. Okay. So the next one that we're going to look at is P or Q. And you can pause the video here. But for this one, if we see that it's P or Q, at least one of them needs to be true. And so in this case, it would be true. Since P is true, and using an OR gives us a true. Okay, the next one we can try out is P and R. And once again, for Python, we need to use this one actually. So P and R, what would this give me? Well, for and, everything needs to be true, right? So in this case, we have true and false. So if we have true and false, well, that actually gives me false because not everything is true. So actually, sorry, this gives me false. Okay, the next one we're going to look at is, let's see what the value of not Q and S. All right, so let's first realize something. For these kind of expressions where there are brackets around, we should realize that we need to evaluate whatever is in here first. So Q and S. So, well, that gives me false and true. Since it's false and true, everything needs to be true for this to be true. Well, there's at least one false in here, so it's actually false. So by doing it step by step, we can see that this is not false. And well, if we're saying this is not false, well, not false just gives me true. So the final answer would actually just be true. All right, so that's D. The next one let's try out is not Q. So let's say not Q and S. All right, so you might be tempted to evaluate Q and S first, but there's actually something similar to numbers where there's a order of operations. And one way you can remember the order of operations is the simple 3-letter acronym, just NAO. And basically what this means is this is not, this right here is and this right here is or. So these go in value. These basically will come in the precedence order. So you always want to evaluate nots first, then you want to evaluate ands, and then ors. Now, obviously, if there's brackets around them, you want to evaluate those. But this is generally what we want to evaluate in this order. So the nots first, the ands, and then the ors. Okay. So for this one, let's look at it closely. So not Q, so not false gives me true. And, and we want to look at S, which is also true. So with the condition of and, we need everything to be true. And so in this case, true and true, this simply just gives me true. Okay, cool. So that was E. The next one let's try out is F. So let's say, for example, and let me make this a little bigger. Let's say, for example, we had S and not Q. All right, so let's evaluate this step by step. S is true. And we have not Q. So not Q gives me true. And so true and true. This very simply gives me true. All right, so that's F. The next one we're going to try is G. And let's think about one. Let's say P or not S. So we're evaluating this in the NAO order. We have to evaluate not S first. So not S actually gives us false. And we're going to say P is true. So we can take that directly. We have an or between them, true or false. Well, we know that with or, at least one of them needs to be true for it to be true. So this is simply true. Okay, cool. Let's try another one. Let's say, for example, let's try some variable h. Let's say not P and let's say not Q. Okay, so let's evaluate the nots first. So not P actually gives me false. And not Q gives me true. And there's an and between them, so false and true. and needs everything to be true for the final value to be true. So this actually gives me false. Okay. The next one let's look at is, I guess we could try this one. So I think is the next letter. We can say S or not Q and R. Okay, so we need to evaluate what's ever in the parentheses first. And then within the parentheses, we see that we have this not. So once again, NaO, we need to evaluate the nots first. So here we have not Q, which gives me true, and R, which is true as well. We can see that S here is true. And so if we say true or true and true, well, we can say, let's evaluate this true here. So true and true, remember, and needs everything to be true for it to be true. So this would be true or true. And with true or true, well, true or true actually is just the same thing as true because or requires there to be at least one true. Okay, and for the final one, let's look at, for example, we could say, okay, let's try P is, let's say P is Q or R. So first evaluate whatever in the parentheses. So P, so let's actually evaluate those. So Q is actually false. And then we have or R, which is false. Then we basically have false or false. So false or false gives us simply false. And well, if we say P is false, well, P is true here. Well, in this case, true is false is actually false because true is not actually false. So this would actually give me false. Okay, so let's jump into idle and see this in action. Okay, so now we're in idle and let's actually check out all those expressions that we've seen that I showed you previously and see how they work. So once again, we need to declare and initialize all of our variables. So let's say P is equal to true. Let's say Q is equal to false. R is equal to false as well. And S is equal to true. All right, so for the first one, we had not P. So with not P, since P is true, it's going to give us false. The next one we had was P or Q. Since or needs at least one true, this is going to be true. The next one we had was P and R. So P and R, we can see and is very restrictive. It needs everything to be and, so this would be given false. If we said not, and we said Q and S, so Q and S, that actually gives me false, right? Q is already a false, so this we already know this whole thing is going to be false. And then if we negate it, it would be true. If we did not Q and S, so we need to express the nots first, right? We need to do the nots first. We have true because this is false already. True and S, so true and true, that gives me true. If we do, for example, what was the next one? I think it was S and not Q. So evaluate not Q first, that's true. So S is true and not Q is true. That gives me true. If we did, for example, P or not S gets evaluated first, so that's false. P is true, so or needs everything to be at least, or requires there to be at least one true, so this gives me true. If we did not P and not Q. So not P is going to give me false. Not Q is going to give me true. So false and true. And requires everything to be true for it to be true. So this is false. If we did S or not Q and R, well, for this one, we can see that we evaluate this first. So not Q, that's going to be false and then turned into a true. So true and R is false. So true and false, that gives me false. S is already true, so true or false. Well, true or false, or requires there to be at least one true, so this gives me true. And the final one was P is Q or R. Evaluate the parentheses first. So Q or R, we can see that gives me false. So is true equal to false? Well, no, it's not, so this gives me false. So in this video, you learned about the Boolean arithmetic and Boolean expressions using Boolean operators. That was a lot of Boolean, but if you get the hang of this, it'll become a very powerful tool.